In general, majority of the Lewis dot structures will involve covalent bonds rather than ionic bonds. A covalent bond is between a nonmetal and a nonmetal. So rather than transferring electrons, they will be sharing electrons. The rules below will help you draw the Lewis dot structure for covalent bonds. Step 1, you're going to count the total valence electrons for every single element. If it's a cation, whatever the charge is, you're going to subtract the charge from the total valence electron. If it's an anion, you're going to add the charge to the total valence electron. Step 2, central atom is the least electronegative. Hydrogen will never be in the middle because it can only make one bond. Hydrogen is located in the first energy level, and the first energy level has only one orbital, which is the s, which can have a maximum of 2 electrons. Step 3, follow the octet rule. In general, everything wants to have 8 valence electrons. The exception to the rule is hydrogen. Hydrogen can have 2 electrons max. Boron and beryllium can have less than 8. It can have 8, but in general it will have less than 8. Periods 3 through 7 can exceed the octet, so they can have 8 or more. And the reason they can have more is because they have empty d orbitals where the extra electrons can be placed. Step 4, you're going to start with a single bond. A single bond can be represented by 2 dots, which is 2 electrons, or a line that represents 2 electrons. If the single bond doesn't work, you try it with a double bond. And a double bond is 2 pairs of electrons or 2 double lines. If the double bond doesn't work, then we try it with a triple bond, which is 3 pairs of electrons or 3 lines. We continue to do this until the octet or the duet rule are filled and the total valence electron of the drawn Lewis dot structure matches the valence electrons that we counted in step 1. If the electrons do not match, you need to redo the structure until it matches while it fulfills the octet and duet rule. Step 5. For ions, you must use brackets. You place the Lewis dot structure in the middle, you put brackets outside and put the charge as a superscript right here on the outside. Step 6. Resonance structure are multiple structures for the same molecule to account for the electron and the bonds. You will usually see resonance structure if there is a double or a triple bond present. The resonance structure are separated by a double-headed arrow. 7. Formal charges. Formal charges show you the stability of the Lewis dot structure or the molecule. The lower the formal charge, the more stable the structure. So you could determine the most stable structure if you have multiple resonance structures by calculating the formal charge. Number 8 is probably the most important step. You always recount the electrons. After you draw the Lewis dot structure, count all the electrons, the lone pairs, the bonded pairs, and then make sure it adds up the total valence electrons that you started with. If they do not match, your Lewis dot structure is incorrect and you need to redo it. We're going to draw a Lewis dot structure for Br2. We know this is a covalent bond because Br is a nonmetal and there's 2 of them. So step 1, we're going to count the total valence electrons. Bromine has 7. There are 2 bromines So there's a total of 14 valence electrons. Step 2 tells you to start with the least electronegative in the middle. Since there's only 2 atoms, they're going to be side by side. Next, we're going to start with the single bond. So a single bond is a pair of electrons, or you could draw a line. Unlike ionic bonding, we do not follow Hund's and Pauli exclusionary principle. We fill the octet and duet rule. So if I look at bromine on the left, bromine on the left has 2 valence electrons. To fulfill the octet rule, we need 6 more. So we're going to draw these in pairs around bromine. It still has 4 orbitals. When I draw 6 electrons or 3 pairs of electrons, bromine now fulfills the octet rule and it is happy. Now I'm going to repeat the procedure for the bromine on the right. It already has 2 electrons that is sharing with bromine. So it needs additional 6. I'm going to draw 6 electrons around bromine. The bromine on the right now has 8 total electrons and it fulfills the octet rule. Now you're going to recount the number of electrons. There's 2, 4, 6, 8, 10, 12, 14. And how many electrons do I need? 14. So this is the correct structure. So the correct structure of bromine looks like this. We could redraw the structure the following way. These structures are exactly the same. These outside, all of these are called lone pairs because they are paired together, but they are by themselves. Right here and right here, these are called bonded pairs because they are bonded between 2 different elements. Pause the video, try HCl, O2, and NH3 on your own, and then check your answer. Oxygen O2, this is a covalent bond between 2 nonmetals. So first we're going to find a total valence electron. Each oxygen has 6. There's 2 oxygens, so there's a total of 12 electrons. They're going to be side by side because there's only 2 elements. So we're going to start with a pair of electrons in the middle that they're going to share. The oxygen on the left needs 6 more to fulfill the octet rule. The oxygen on the right also needs 6 more to fulfill the octet rule. The oxygens are happy because they have 8. If I count the total number of electrons, I have 2, 4, 6, 8, 10, 12, 14. So my Lewis-Dot structure has 14, but my total valence electron is 12. So my structure is not correct. That means there is a single or double bond. Since the structure I drew has 14 electrons and the total valence electron is 12, it exceeded by 2 electrons. 14 electrons minus 12 electrons is 2 electrons. 2 electrons represents 1 bond. So that means this structure, O2, has an extra bond. So instead of having a single bond, which is incorrect, oxygen has a double bond. So oxygen shares 2 pairs of electrons in the middle. I'm going to look at my oxygen on the left. Since it has 2, it only needs 2 more. I'm going to do the same thing for the oxygen on the right side. It already has 4, so it needs 2 more pairs of electrons. Both oxygens are happy because it has 8 valence electrons. Now I'm going to count. This is 2, 4, 6, 8, 10, 12. That's what I need. So this is the correct structure. The correct structure is O double bond, and it has 2 sets of lone pairs on the outside. HCl. Hydrogen has 1 valence electron plus 7 from the chlorine. This is going to be 8 valence electrons. Since there's only 2 atoms, they're going to be right next to each other. And I'm going to start with a single bond. Hydrogen is already happy because hydrogen can only have a maximum of 2 because it has 1 orbital, and that is the 1s. Hydrogen fulfilled the duet rule. No more electrons could go in. Now I'm going to look at chlorine. Chlorine has 2 valence electrons. Chlorine is sharing 2 electrons already, so it needs 6 more. So 1, 2, 3, 4, 5, 6. Chlorine is happy. It fulfilled the octet rule. Now I'm going to count 2, 4, 6, 8. 8 valence electrons. The Lewis dot structure has a total of 8 electrons, which matches. So this is the correct structure. So it's going to be HCl, 3 lone pairs around the Cl. NH3, 5 valence electrons from nitrogen, plus 3 from the hydrogen. So that's a total of 8 electrons. The least electronegative is supposed to go in the middle, which is actually hydrogen. But hydrogen can never be in the middle because it can make only 1 bond. Nitrogen, and we're going to start with 1 hydrogen here. Start with a hydrogen here, a hydrogen here. The hydrogen is happy. It has 2. It fulfilled the duet rule. This hydrogen is happy. It has 2. It fulfilled the duet rule. This hydrogen is happy. It has 2. It fulfilled the duet rule. Nitrogen already has 6 from sharing with the hydrogen. It needs a pair. So now nitrogen is happy. So if I count, there are 8 valence electrons. So this is correct. Write it like this, or you could leave it as is. These are all the same structures. You could also leave the structure in this format. I just draw the circles to help you out because it's easier for you to count the electrons when you know how many are already in the circle. This is the better structure, but I'm not going to mark it wrong if you put the circles around it. It just helps you count. Pause the video, draw the Lewis dot structure for the following compound, and then check your answers. Count the total valence electrons. There are 2 hydrogens, each with a valence of 1. Plus oxygen has 6. This is a total of 8 electrons. The least electronegative element goes in the middle. However, hydrogen cannot be in the middle, so oxygen is going to be in the middle. We're going to start with 1 bond and fulfill the octet and duet rule. If I look at hydrogen, it's already fulfilled the duet rule, so it's done. So is the next hydrogen. The oxygen currently has 4, so I need 2 more pairs. And if I count, oxygen has 8, so it's happy. So if I count the total number of electrons, so it has 8 electrons, so it matches. On B, we have 2 nitrogens, so 2 times 5 valence electron plus 2 times 1 from the hydrogen, so there's 12 electrons. Hydrogen cannot be in the middle, so we're going to have nitrogen. Compounds that are like this, these are going to be symmetrical. So one of the hydrogens is going to be on one side, the other one is going to be on the opposite side with the nitrogens in the middle. Hydrogen is already happy. It has 2 pairs of electrons. Hydrogen on the opposite side is happy. It has 2 pairs. So now let's look at the nitrogen. Nitrogen has 4 electrons, so it needs 4 more to make 8. The other nitrogen also has 4, so it needs 4 more electrons to make 8. So if I count this, I have 2, 4, 6, 8, 10, 12, 14. This exceeds the 12 that we need. So we could figure out how many extra bonds we need. So my Lewis dot structure had 14 minus my valence electrons I originally counted, which was 12. So we have 2 extra electrons. 2 extra electron represents 1 bond. So there's an extra bond. That bond must go between nitrogen and nitrogen. Why? Hydrogen can only form 1 bond, and it already did. This structure is incorrect. So nitrogen is going to have a double bond. And this is hydrogen. This is hydrogen. Now we're going to count. Hydrogen has 2, so it's happy. The other hydrogen has 2, so it is happy. If I look at nitrogen, now it has 6, so it only needs 2 more electrons, or a pair. The other nitrogen also has 6. It only needs a pair. If I count the total number of electrons that are bonded and non-bonded, I'm going to have 12. I have 2, 4, 6, 8, 10, 12. This is why you always recount your electrons to make sure they match the original. C is hydronium ion. There's 3 hydrogen, each with 1 valence electron, plus oxygen, which has 6. It has a charge of +1, so I need to subtract it. This is a positive ion, so we need to subtract 8 electrons. My central atom is again going to be oxygen, because hydrogen cannot be in the middle. Hydrogen has 2, so it fulfilled the duet rule. It's happy. The bottom hydrogen also has 2, so it fulfilled the duet rule and it's happy. And the hydrogen on the right side fulfilled the duet rule, and so it's happy. If I look at my oxygen, it currently has 6 electrons, so it needs 2 more. So now I count, there's 2, 4, 6, 8. This is the correct structure for hydronium ion. We need to include brackets because this is an ion with a charge on the outside. So your structure will look like this. It's a charge. You can also draw it like this. This is correct. All of these structures are acceptable. Odd electron Lewis-Dot structures. These are called free radicals. They usually involve nitrogen and oxides or oxygen. If we have nitric oxide or nitrogen monoxide, we know the formula for nitrogen monoxide is NO. Mono is the prefix for 1. So if I find the total valence electron, this is 5 for nitrogen, and oxygen has 6. This is a total of 11 electrons. I'm going to start with a single bond, and they're going to be next to each other. Again, I'm going to fulfill the octet rule. So if I do that, nitrogen needs 6 more to have 8. Oxygen also needs 6 more to have 8. If I count the total valence electrons, it's going to be 2, 4, 6, 8, 10, 12, 14. It's 14, and it exceeds the total number of electrons. So I'm going to see if there's extra bonds. So extra bonds are determined by subtracting the Lewis-Dot structure you drew minus the valence electron that is required. So this is going to be 3 electrons. Since I cannot have a bond and a half here, I know there's going to be 1 extra bond. So if I redraw it, the extra bond is between nitrogen and oxygen. So now nitrogen has 2 bonded. So if I look around nitrogen, it already has 4. So I need 2 pairs. So now there is 8. Around oxygen, there's already 4. So I need 2 pairs to have 8. However, we have an odd electron. So right now, with the structure I drew, I have 2, 4, 6, 8, 10 electrons, and I need 1 more electron. That electron will go to the oxygen because it is the most electronegative. The odd electron always goes to the most electronegative element. In general, free radicals are very unstable. So what they do is they look for other free radicals and find dimers, and they will combine where the odd electrons exist.